So on the first page of the NB homework, you're given a parametrized curve, square root of 3 cosine t, 2 sine t, cosine t. And question 4 is asking us to show that this curve has a constant speed. And so you correctly are identifying, and this was something that we saw in the activity number 9.7.4, that having constant speed, a curve having constant speed, is the same thing as that curve's velocity vector being perpendicular to its acceleration vector. So this is the following the hint way of approaching this. So we can show that r prime of t, the velocity vector, is perpendicular to r double prime of t, which is the acceleration vector. So let's do those calculations just together real quickly. This will again go into the homework as a nice little hint. So r prime of t, so take the derivative of the cosine gives me a minus sine, the derivative of the sine gives me a cosine, and the derivative of this cosine gives me a minus sine. So minus radical 3 sine t, cosine t, minus sine t. Oops, and let me use angle brackets to set that off here. So there is my first derivative. Take the derivative of that. This will still be negative 3, but now it's cosine. And then I'll have a minus sign from here, and I'll have a minus cosine from this one. Oh, and now I see what you're saying. That if you take the dot product of these two things, it might not be the case that this. So what would we want this dot product to come out to be if we're trying to show that these are perpendicular to one another?
I have a question.
Yeah.
Should there be a 2 in the middle function? Because it says 2 sine t.
Oh, it does. Yes, I lost that too. Sorry. So let me wedge that in here. 2 and then minus 2. Yeah, sorry about that. Okay. So what would we hope would happen when we take this dot product?
It should add up to 0.
Yeah. So that's the hope here. Question mark, right? And so we might have a little bit of trigonometry to do, but actually, let's see. Actually, I don't. Maybe we don't have much trigonometry to do. So when you do this dot product, these square roots of 3 are going to multiply together, right, to give me 3 sine t times cosine t. And then my 2 and my minus 2 here are going to combine together to give me negative 4 cosine t sine t. And this minus times a minus is going to give me a plus 1 sine t cosine t. So I think it actually does work out. Let me just double check the derivative that you had. Yeah, that derivative looks right. But again, so in your original idea, you were just trying to find the magnitude of the acceleration vector, which is not the same thing as the rate of change of the speed.
Right, right.
The rate of change of the speed is, related to this dot product of velocity with acceleration. So yeah, I think the algebra does work out. I will sort of leave that computation to you. But again, I think the purpose of this problem, the main goal, was to get us back into that realization, right, that it's the angle between velocity and acceleration that tells me whether parameterization is speeding up or slowing down.
So is there some kind of trig that we have to use to get it to equal 0? Because when I did it and I graphed it too because I wasn't convinced that it was the same, and I didn't like a perfectly horizontal 0 curve. So I
I
was
actually, so that's what I was thinking when I looked at this just a minute ago, but it turns out I don't think so. I don't think we need a trig identity to show that this one is 0. Make sure you're doing a dot product and not a cross product. If you try to cross product these two vectors, we probably are going to get something that, actually, that'd be an interesting thing to look at. If you take the cross product of these, you would probably end up getting something that a trig identity would help you to simplify. But actually, no, because when I take the dot product, I'm only multiplying, the first components by the first components, for example, right? And so when I multiply these out, I'm going to get something which is a multiple of sine t cosine t. And then the same thing is going to happen when I multiply these components. I'm going to get a multiple of sine t times cosine t. And then the same thing with these components as well. And so all of my terms are going to be components of sine t times cosine t. Right? Multiples of sine t times cosine t. So I can factor out those multiples and then show that those multiples actually add up to 0.
Okay. Okay.
Yeah. So what we end up getting is 0 times sine t cosine t when we do this dot product. So make sure that you're not only multiplying but also then adding those results together, because the dot product needs to give you a scalar at the end of the day.